For grade 10 mathematics, we'll basically have 8 chapters. So firstly, we will review the linear equations, and this will be basically done in this recording sessions. And after we have a recap on the linear equations, we will start to learn the first chapter, which is called the system of linear equations. By system of linear equations, it means that we will have more than one linear equation. So it can be 2, 3, or more. And we want to learn about the relationships between those linear equations, both graphically and algebraically, and to find whether there are some solutions to our variable x or y values. And next, we'll learn about the analytic geometry, where we'll learn about the line created by any 2 points, causing some line segments, and learn about how to find the slope of the line segment and maybe the equation of that line segment as well. And after learning about the introductions for line segments, we'll do the line segments on some circles or other shapes to find whether there are relationships between those line segments. And after that, we'll have a large chapters which are all the way from chapter 3 to chapter 6, talking about the quadratic relationships or the quadratic equations. So firstly, we'll start with the graphs of the quadratic relations, and we'll definitely find the differences between our previous linear relationships or linear equations. Where in linear equations, we have straight lines, both the graphs for quadratic relationships, they are all curves. And then we'll learn about how to factorize in some algebraic expressions for quadratic relationships. And we'll have a lot of methods to do the factorizations. And what is the factorizations? It's basically the anti-steps for the distribution rule we first learned in grade 9. And later, we'll talk about how to apply quadratic models, which means that we want to use the factorizing techniques and the graphing techniques to solve for some real-world quadratic problems. And we'll also know some techniques on solving those kind of problems as well. And after that, we'll focus more on the algebraic ways, which are the quadratic equations. We'll learn what is a quadratic equations, and we'll learn how to solve for the quadratic equations or how to simplify the quadratic equations by the factorizing techniques. And also we'll apply some transformations learned in grade 9 to learn how the graphs looks like for all kinds of quadratic equations as well. And for the last 2 chapters, they are talking about the trigonometries or triangles. So basically, we are learning more comparing to the grade 9's triangles, where we only learn about how to identify the hypotenuse. And in this class, we also learn 2 more things, which are called the adjacent and the opposite. And now we'll discuss the relationships between the 3 sides of a triangle, and they are usually called the trigonometries. And after that, we'll use the relationships or the ratios between the 3 sides of the triangles to learn about the acute triangles and about the trigonometry in triangles. To start this recording sessions, we'll both basically do some recap or review on previous contents for linear equations. So I have several questions for you guys, and it's a good time to pause the video and think about the questions. And after you have the solutions to the 5 questions shown on the PowerPoints here, you can just continue the videos. Okay, great. Hope you have some answers or some thoughts on the questions on the problems shown here, and hope you have reviewed some of the concepts here. So firstly, let's go over the choices or the concept. Firstly, we have x-intercept, which means that the intersection between our x-axis. And similarly, the y-intercept will be the intersections for our y axis. And for the third one, equation, it basically means that there's a left-hand side and a right-hand side, and they are connected by an equal sign. So the left-hand side will equal to some right-hand side, and they will consist of an equations. Variable usually means some letters, but for the course, we are mostly often to use the x and y notation to represent our variables. And if you have learned more about the variables, they are called the independent and dependent variables as well. Coefficient. Coefficient means that any constant values or known values that are multiplied with the variable. So for example, if we have 5x, then the x will be our variable. And we know that 5 is some multiplier when it's multiplied by the x. Then the 5 will be our coefficient here. Point of intersections. Point of intersections is a more general idea for y-intercept and x-intercept. It basically means that any intersections made by two lines, or even curves and a line, or any weird shapes, they can all have some intersections. And this usually means some points. Solution. Solution basically means that if we have some x values, we want to know about the y values comparing to the x value here. So for the first questions, the place where a graph crosses the x-axis is called the, as we have just reviewed, it is the x-intercept, or number 1. In the blank, for question B, in the blank y equal to 5x plus 2, 5 is a blank of the blank x. So we know that y equal to 5x plus 2, the y will be the left-hand side, and 5x plus 2 will be the right-hand side. And they're connected by an equal sign, which means that they are, or this one is an equation, or number 3. And 5, as it is multiplied by the variable x, so here we have the variable x, it will be the coefficient for 5. For question C, let's x equal to 0 to determine the blank of the y equal to 4x plus 7. So for this one, we have known some x values, and we want to solve for the y. Then, basically, it's, well, you may think it is some solutions, but as we know that if it is intersecting with the x equal to 0, it basically means that it is intersecting with the y-axis. Therefore, for question C, it is actually asking for the y-intercept because it is asking for the point where the line will intersect with the y-axis. So it will be number 2 for question C. And for question D, you can determine the blank 220 equal to 3x minus 10 by graphing the equation y equal to 3x minus 10. And here, because we have known some value for y, or we are substituting the value of y, and want to learn about the value of x, then we are asking for the solution of the x. And for this question, it's asking for the solution using the graphing method. And for the last question, question E, the order pair at which two lines cross is called the blank. So it basically means that the two lines are crossing to each other's, which means that they are intersecting to each other's, and we want to find out the ordered pair. So it means the x and the y coordinate for this point. So it will be the point of intersection. Okay, and for the remaining of this recording section, we'll do 2 more problems, and after that, we'll have a review to finish one problem by yourself. And if you have any questions, just let me know in the class, and we'll also try to we'll also review some of today's content for linear equations during the class as well. So firstly, for the chapter 1, the skills and concept we need to know will be graphing a linear relationships and expanding and simplifying an algebraic expressions. So to graph a linear relationships, we'll basically use 3 techniques or 4 techniques. The first one will finding a table of values, and we're just connecting those values by a straight lines. Or we can find the x and y intercept and connecting the 2 points to find the line as well. And the other one, we're finding the slope and the y-intercept. Now we can draw a graph based on the y-intercept and use the slope or the steepness to draw the line. And the last method will require a graphing calculator. And in this class, if you don't have a graphing calculators, we'll use a website called Desmos.com. It is an extremely helpful website where you can utilize during your daily studies or homeworks or trying to figure out some relationships between the equations or the graphs of the equations as well. For expanding and simplifying an algebraic expressions, we usually use an algebraic title model to visualize and simplify an expression. So, for example, if some expressions have the brackets, we can use the distributive property to expand it, which means that we are removing the bracket but keeping the equation or the expression the same comparing to previous one. And we can also add or subtract the liked items. So for example, if we have 5x plus 6x, the x will be the liked items. So we can factorize it by 5 plus 6x. Or we can directly calculate it by adding the liked items. So it will be 11x by using either methods. And let's see an example. We want to graph the equation 3x plus 2y equal to 9. And there are 2 solutions, either using x and y intercepts or using the slope and y intercept. So firstly, let's examine using the x, y intercept. To use the first method, we need to first determine the x and y intercept. So firstly, we'll let y equal to 0 to find the x intercept. So we are replacing y by 0. Our equation will look like 3x plus 2 times 0. We replace y by 0 equals to 9. And simplifying 3x equal to 0. And we'll get x equal to 3. Which means that the graph will pass through the point 3, 0. And similarly, we can do the similar steps to find the y-intercept as well. Oopsie. So here, I just erasing the values here. Let x equal to 0 to find the y-intercept. And by setting x equal to 0, we are replacing x by 0, keeping the y, simplifying, and solving for y. Now, we know that the line will passing through here. I will replace the 9 over 2 by 4.5, just calculating the decimal value here. And we can know that, oopsie, the graph will pass through 4.5. Now we have the 2 intercept. And the next steps we'll do is to find the 2 points here and connecting the 2 points. So on the graph, let's say we have 1, 2, 3, 4, 1, 2, 3, 4, and 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Our points we just found will be 3, 0, and 4.5, 0, 4.5. And now we only need to connect the 2 points here to find the graph of our equation. And we also need to remember to label the line as well. Now, let's try to use the slope and the y-intercept to graph the line here. So to use slope and y-intercept, we will need to learn about the slope. And we have already solved for the y-intercept, so we'll skip that and we'll label that the y-intercept will be what we just solved, 0, 4.5. Now, how to find the slope? We'll need to simplify the equation to our standard form, which is y equal to mx plus b. And the m will be the value of m will be the slope we are looking for. So, firstly, let's copy the original equations. And we want to move all the x values to the right hand side. So it becomes 2x equal to negative 3x plus 9. And we want to remove the factor of 2, or the coefficient in front of the y value. Now we need to divide all equations by 2, or all terms by 2, to simplify the coefficient for y. And now calculating, we'll get y equal to negative 1.5x plus 4.5. And you can also see that the b value will represent the y-intercept as well. Now we know that by going right by 1 unit, the y will go down by 1.5 units. So on the graph, we first need to find the y-intercept. So let's label the scales first. And firstly, we need to find our y-intercept, which is 0, 4.5 here. And now, with this slope, we know that while the x is increased by 1.1 unit, the y will decrease by 1.5 unit. So it all goes to value of 3. And now we only need to connect the 2 points to find our graphs. And ideally, it should passing through the line like the point 3. So let's try to adjust the scales here, because we are all graphing it by hand. So there will be some arrows here. Oopsie. Yeah, now here we go. So that's basically the techniques we can use to graph a linear line. And I would recommend you to try the second method by yourself, because it requires some reviews or your knowledge on the definition for slopes and how to find the intercept using the standard formula and the value of b. Now for example 2, we want to expand and simplify this equation. 2 times 3x minus 1 plus 3 times the sum of x plus 2. And we can use 2 methods. Firstly is using an algebra tile model, and the second one is using symbol. So like an algebra tile model, I can just draw it very quickly. So for the first one, we will have 3x minus 1, which means that we have 3x here minus 1 here, and another minus 1 and 3x here. We have two of them because they are times by 2. And similarly, we have 3 pairs of x plus 2. So by x plus 2, we know it can be understood as 1, 1, and a x. And also, two more pair of x plus 2 as well. Now we need to put all the numbers together and put all the variables together. And now we count that we have negative 1, negative 1, 1, 1, 1, 1, 1, 1, and we have all the x here. And the only thing is we need to count the values here. So we have negative 1, negative 1, plus 1, plus 1, plus 1, plus 1, plus 1, plus 1. So this will be a value of positive 4. And we have a total of 9x here. So it will be 9x plus 4. This method will be easy, understandable, but it can be a lot of time consuming. So that's why we'll usually use the symbols. And for discussion, it's the distributive method. Firstly, I will just copy the original equations here. And now, by distributive, I can distribute the 2 into the bracket and 3 into the bracket as well. Now we'll derive 6x minus 1 times 2 plus 3x plus 2 times 3, which is 6. And I will simplifying the liked items, or add or subtract the liked items here. And I will derive my final solution, which is 9x plus 4. Hope you still remember those knowledges, and I have a practice problems for you to try after this recording sessions.